Joshua, please tell me, is it possible to use simultaneously archive command and replication slot? For example, archive command for backup and point-in-time recovery, and replication slots for replication.
Yes.
They don't interfere and no. Thank you.
Okay, I'm going to go ahead and try and get through the rest of at least this part of the curriculum. As a reminder, if we don't get to the logical replication part, and depending on what happens, I might just cut it off so that you guys can ask questions instead, because I've got, I really enjoy an interactive crowd, and you guys have a lot of questions, and I like us all learning from each other. So I'm going to try and get through at least the binary portion, and depending on what time it is, we'll do some more questions. And if you guys don't have questions, then I'll move on to the logical replication portion. If we don't get to logical replication, as a reminder, it is the exact same content that I am giving tomorrow. I think it's 2 p.m. So we can do that again. It's not a big deal. Okay, so we're configuring the secondary here. The first thing that we have to do is be able to take a PG-based backup, or a base backup of the primary. So first, we're going to assume that our primary is at IP address 192.168.1.10. I'm just going to say 10 and 5 from now on, just to keep things simple. We will need to ensure that our secondary, which is at IP address 5, can access the primary. We do this by editing the PGHBA.conf. As you can see here, we got local replication all peer, host SSL replication all 192.168.1.5 MD5. I am opening up Postgres to allow connections from .5 and .5 only. Now keep in mind this is a IP/CEDAR address, so it doesn't have to be a single IP. You could open it up to a whole network just by changing the net mask. Okay, it's just I'm keeping it simple. The above will allow any role who has the replication attribute. This is the key. You have to have the replication attribute. So when you create your replication user, I'm cheating here. I'm just going to use Postgres. You probably shouldn't do that. You should probably have a separate user for replication. But just for simplicity's sake, when you create the role, you would say create role foo, log in with replication. Okay, and it means that the user that you are creating has the ability to connect to Postgres as a replication user. Once I've made that change, I've saved it to disk, I need to reload the configuration file. Now there's a couple of ways to reload the configuration file. The first one is you can grab the PID of the parent postmaster process and you can hup it. Don't do that. That's a recipe for disaster. It works every time until you accidentally type the wrong command and you kill it. So don't do that. The other thing is if you run on Linux, you can use like systemctl reload on the Postgres service. I don't like that version. There's nothing wrong with it, but I don't like it because I don't like anyone to log into the database server unless required. And when I mean log into the database server, I'm talking about the OS. Now, obviously, I'm already at the OS level because I had to edit my pghba.conf, but I want to limit how much time I'm in the OS of my database server at any given point for reliability reasons. So I'm in PSQL. I say, hey, I'm going to connect port 5433. And it tells me I'm connected. And I say, select PG reload conf. It is returned true. Therefore, I know that all current changes to the PostgreSQL.conf, the PostgreSQL.auto.conf, the PGHBA.conf, as well as a couple of others that we won't get into, any settings that can be changed via a reload have been changed, and that includes these network settings. Now we're going to talk about PG-based backup. PG-based backup is a great utility. It has its pros and cons. Do I cover that? I thought I did. I had a huge paragraph about it. I guess I forgot. I may have accidentally deleted that paragraph. Okay, so what is PG-based backup? PG-based backup is a utility that ships with Postgres. It is highly inefficient, but it's fine for what it does. If you have a large database, and when I say large, I'm not talking about 50 gig. 50 gig is not large. I know it feels big, but it's not. I'm talking 500 gig. If you have anything that's 500 gig, maybe even 250 gig or larger, consider using something like PG Backrest or I think it's called PG Pro Backup, which is from Postgres Professionals, because it will do a multi-threaded copy, which means that you're going to be able to utilize as much of your resources as possible, and you'll get the copy done faster. But if you're under that, if you don't mind that the base backup might take an hour, for example, PG base backup is just fine, and it makes things pretty darn simple. Let's walk through some of these options. So obviously the usage is PG base backup option. Option 1 is -D, receive base backup into directory. And that is exactly as it says. If you say -D data, when it connects, it's going to pull that base backup right down to your local machine into the directory data. And when you are done, if you do nothing else, and you were to say PGCTL-D data start, a base backup of Postgres would come up. Okay? -F format, do we want plain or tar? For this purpose, we want plain, because we're not actually taking a backup. We're actually creating a replica. If we're creating a backup, something that we want to archive, send off to tape or Glacier or whatever, then you would use tar, because it would wrap it all up into one nice little ball, and you could take that ball and put it on a remote drive or whatever you need to do. Max rate, you can set the maximum transfer rate into the data directory, whether it be kilobits or megabits or whatever. This is an interesting feature to me, and it's actually the opposite of what I expect or want. And that when I take a backup, I want it to go as fast as possible. I want my backup started and done and reliable. However, we have to recognize that not all infrastructure can support pushing 120 megabytes a second across the wire. Sometimes you got to slow it down. This is one reason why you really want to consider a situation where the public interface to your primary is not the same interface to your secondary. So in hardware terms, we want ETH0, Ethernet 0. That's where my application and my users connect. But Ethernet 1 is where my secondary connects. That way, as long as I don't overload my disks, I can transfer my backups as quickly as possible. Write the recovery configuration. This is a nice utility in that if you say write recovery configuration, it will automatically create a basic recovery.conf to bring up your standby. It's not going to have everything you need to actually connect for streaming replication necessarily, so you definitely don't want to double check it. You don't want to just start it, right? Slot name, replication slot to use. The replication slot must exist ahead of time, but you can, instead of streaming or fetching the X logs via the PG base backup utility, you can tell it when you write the recovery.conf to go ahead and connect to the replication slot so that it will catch up when you start it. No slot, prevent the creation of a temporary replication slot. So if you don't use slot name, but you use no, and you do, it will create a temporary replicate. Remember when we were talking about replication slots, we can create a temporary one. That slot would only, since it was temporary, would only exist for the session. That's what we're talking about here, is PG base backup has connected, it's pulling a backup and it's created a temporary replication slot for that session so that you can get all the logs. Table space mapping, old dir, new dir. So one of the problems that we have is that a base backup, since it is a binary identical backup to the primary, you can't necessarily put the base backup in a different location on your secondary. It's going to assume, if you're using table spaces, that the literal paths still exist. So if on the primary you have a table space of, say, foo, and it's in /foo, but /foo doesn't exist on the secondary, it's going to fail when you bring it up. So what you're able to do is remap foo to, say, bar, so that it won't fail. Wall method to fetch or stream, include required wall files with specified method. You definitely want to do that. Location for the write-ahead log directory, if you by default move the wall directory. Gzip, if you're using tar output, do you want a gzip? This is actually one of the reasons why I don't like PG-based backup for normal backups versus just a base backup, because gzip is slow. And it's actually not that, I mean, it's a decent compression algorithm, but there are better ones. What I would love to be able to implement here is how, I don't know if folks have seen this, but with the normal tar utility, you can tell it to compress, but then you can also tell it which compression to use. And have you guys ever heard of PGZ? Okay, PGZ is parallel gzip. You can actually tell it, hey, I have 16 cores. I'd like to use 12 of those to compress my data so that it goes much, much faster. I wish PG-based backup would allow us to do that. And then obviously your compression level. General options, checkpoint, fast, or spread. This is very important. By default, if you say checkpoint spread, when it starts the base backup, it is going to use checkpoint timeout divided by checkpoint completion target to issue the checkpoint. And if you have a checkpoint of 2 hours, a checkpoint timeout of 2 hours with a checkpoint completion target of 0.5, it is going to take an hour for your backup to start. So instead, you can pass fast, in which case it will immediately just checkpoint. Now, the downside to that is, depending on how many dirty buffers you have that need to be written out, it can be a short but significant performance hit. I mean, you're basically just all of a sudden trying to shove, a gallon of water down a straw. So you do need to be aware of that and be careful. Label, set the backup label. When you use the manual ways to do this of PG Start Backup, you have to set basically a title of the backup. No clean, do not clean up after errors. That's useful if you're trying to do debugging. You get an error, it aborts out, by default cleans everything up. Well, then you could run it again with no clean, and then you can find out why did it die. No sync, do not wait for changes to be written safely to disk. It's kind of like running with fsync off, but I would be more inclined to be willing to use this option because it does reduce the amount of I/O on the backup itself. Progress, show your progress. Verbose, be verbose. Version, who cares? Show this help, then exit. And then, of course, your standard connection option string. So you got your database you want to connect to, what host, what port, time between status packets sent to the server, connect as a specified database user, don't prompt for a password, or force a password prompt. The force a password prompt is a legacy thing. There were some versions way, way, way back where for some reason, if a client would connect, every once in a great weird while, I don't know if it was a race condition or something, it wouldn't prompt for the password and you could never log in. So they added this feature and now you can force a password prompt. I have never actually, in 20 years, I've never actually seen the bug happen. but I have seen reports of the bug happening, which is why it's there. I have not seen it in any recent iteration. In its simplest form, taking a base backup can be as simple as this. PG base backup -H 192.168.1.10 hyphen or -U Postgres -D data, put my backup into the data directory. I need to connect via 5433, and I need to stream my Xlogs. This will place a complete base backup within the directory data, ready to go with whatever modifications I want for hot standby. That's your standard way to do a PG base backup. And I am definitely missing a paragraph. Apologize for that. The second way is an rsync method. Anyone who's used rsync knows the glory of rsync. It is a wonderful, yes. Oh, you were just saying I've used it? Okay. I'm sure, who here hasn't used rsync? Oh, you're Windows people though, right? No? Okay, so rsync is fantastic. You should use rsync instead of CP. You should use rsync instead of SCP. You should use rsync instead of SFTP. And if you're on Windows, God help you, use Robocopy. It's a very similar thing. The great thing about rsync. Oh, sorry. So the great thing about rsync is that, one, it verifies the copy. Okay? It makes sure that what you have over here that you put over here is identical. It also does incremental updates. So if the copy fails and you restart it, it won't recopy the previous stuff. Things like that. So if we're using the rsync, it's also easily scriptable. So if we are using rsync, it is a popular method for creating base backups. It's useful in that it can be used to verify the backup while it is being archived. It also uses the SSH protocol by default, which allows for a lot of customization. However, the use of rsync does not work out of the box, and it's best that it be scripted if it's to be used more than once. Specifically, what I liked about scripting rsync is that a member of my team created a multi-threaded rsync. So when we're copying 5 terabyte, 10 terabyte, 20 terabyte databases, we are not copying over a single thread. We can say use 4 or 8 or 12 as long as we have enough I/O in order to do that. So here are the steps to a successful rsync backup. We'll assume that you understand SSH authentication, either via SSH keys or password. If you're using passwords for SSH, you're doing it wrong. Use keys. That's kind of the whole point. As previously mentioned, the use of rsync does not cover a lot of implicit features that are included in PG-based backup. Therefore, we must execute a few steps in advance for an appropriate backup. So the first thing we want to do is we want to create our replication slot for the backup. PSQL-U Postgres-H 192.168.1.10. Select PG create physical replication slot. My backup true. Remember when we first talked about creating a replication slot, we want the true there so that it immediately starts recording all the changes that you're going to need to bring up a standby. If you don't put true there, it won't record until you connect, at which point your backup is already invalid. Okay? So it shows that I created it. Boom, there's my backup. There it's LSN location. Don't worry about that. It's not even really all that important unless you're doing debugging. Select slot name, slot type from PG replication slots. Boom, there it is. Slot name, my backup. It is a physical. It's ready to go. I have verified it's there. I can now move on to the next step. In this example, we've connected to our primary and executed the function to create the slot. Talked about that already. Now we need to start a base backup on the primary. Now, of course, we could have done this in the same session. I'm not saying that you should disconnect and then reconnect, but just for the sake of example, in this example, we have connected to the primary at .10 and executed the admin function PG start backup. The first argument is the backup label, basically the title of the backup. The second is whether or not to execute a fast or spread checkpoint, as discussed in the PG-based backup syntax. Again, if you don't say true when you start the backup, you're going to do that long backup because of the checkpoint. It's going to be checkpoint timeout divided by checkpoint completion target. If you say true, it will complete the checkpoint as quick as it can, but it may be a performance hit. With the primary now in backup mode, we can start our base backup with rsync. Using rsync to create the backup for the secondary. The rsync utility is fairly sophisticated, and we will not go through all the options. In a reasonable configuration, retrieving your backup from the primary would be as simple as rsync-auv, user @10, : the location of my data and where I want it to go. So I am copying using SSH. I'm on the secondary. I've connected to the primary, and I'm pulling all the data down. Now, I connected as Postgres for a reason. It's because Postgres owns all the files on the primary. You can't use an unprivileged user. It would have to be whoever owns the files. So on Linux, it'll be Postgres. On FreeBSD, it would be something like PGSQL. Okay? In the above example, we are archiving A, updating U, and being verbose, V. Not necessary. V is not necessary. And if you're scripting it, I don't recommend that you use V because it just creates a lot of erroneous output. It's not even erroneous. It's just not necessary. But for this example, it's useful. And archiving the directory var lib pgsql data into the local directory data. When complete, we now have a base backup. There are still a few more steps. It is also possible to add additional useful flags to rsync, including compression, or what level of compression, and different types of checksum features for added data integrity checking, for example, checksum. Stopping the base backup. Since we've completed the base backup, we now need to stop the backup on the primary. So we do PSQL-U Postgres-C select PG stop backup. In the above example, we have stopped the backup my backup. Note that only a single backup at a time can be running, so you don't need to worry about a possibility of you stop a backup and you stop the wrong backup. You can only, now when I say backup, I'm talking specifically about base backups. Logical backups with something like a PG dump or a PG dump all, you can run multiples of those at a time. But binary base backups, you can only run one at a time. I apologize, I haven't spoke for this long. I did, as you know, I did a training in the morning too, and now this afternoon, and throat's getting a little sore. So now that we've stopped the backup, we need to create the recovery.conf. One of the final steps of configuring replication is to create the recovery.conf file within the data directory on the secondary. And when I say data, I really should say cluster, because I don't want to confuse you. It doesn't have to be named data. But wherever you put the base backup is where you need to create this recovery.conf file. There are quite a few options for the recovery.conf file that apply to not only replication, but high availability and point-in-time recovery. Within this curriculum, we are only going to cover the ones needed for replication. But I will bring up just a couple with the point-in-time recovery because they're very, very useful. With point-in-time recovery, you can restore not only to a point in time, but also to a point in transaction, for example. Meaning, if you know the transaction ID of right when everything blew up, you can restore to exactly that point to figure out what's going on. You can also use what's called restore points, meaning that you can, and this is actually really good for developers. You can have a situation, let's say you're about to deploy a new version of your application on Postgres. And you've got this massive transaction that runs that alters this table, drops this column, updates these rows, does all this stuff to bring your magical application that's going to make you independent billionaires, up to V2. Well, one of the problems with doing that is what if something goes wrong? Well, the nice thing is you can say, I'm going to create a restore point and name that restore point, then do everything. And if the world blows up, you can literally restore just to that named restore point that you know is right before you broke it. It's a very comforting feeling, if you want the truth. All right. First and foremost, standby mode specifies whether to start the Postgres server as a standby. If this parameter is on, the server will not stop recovery when the end of archive wall is reached, but will keep trying to continue recovery by fetching new wall segments using restore command or by connecting to the primary server as specified by primary con info. Now, what do they mean by restore command and or connecting? I believe one of the gentlemen asked about can archiving and replication slots work together, right? That's what we're talking about here. You can actually, while you're taking the base backup, be shipping logs to the standby and configure it in a manner that instead of connecting over the network to get everything from the replication slot, it will restore from the archive logs it already has until it can't, and then it will connect and get all the updates. It's actually a pretty useful way to do it, depending on what kind of resources you have available. The next is your primary con info string. Now, I'm actually skipping over a piece here. This specifies a connection string to be used for the standby server to connect with the primary. In our case, this is what it looks like. It's primary con info, host equals .10, port 5432, user is Postgres, and I'm requiring SSL. Okay? The part that I'm skipping is it doesn't have to be the whole string. You can use what's called the .pgpass file. And the .pgpass file is particularly useful because it's basically the primary con info for every single server you're allowed to connect to. So if I said, I'm just abbreviating here, PSQL.10, it would go to the PGPass file first and get all the information it needs to connect to .10. And what's great about that is I could have .10, .11, .12, .13, 14, 15, and I don't have to keep or memorize or have a spreadsheet or whatever of all my connection strings. I just have one file that it knows how, PSQL and all my other programs know how to interact with. Okay? Primary slot name optionally specifies an existing replication slot to be used when connecting to the primary via streaming replication. When we created our slot, our replication slot, we used the name MyBackup. So I'm telling it in the recovery.conf, primary slot name equals MyBackup. Writing the recovery.conf. The next step is to write the recovery.conf file. When using PG-based backup, you can pass -R, right, recovery.conf, in order to automatically write the recovery.conf file. Not all of it, but most of it. And here's my recovery.conf file. Very simple. Standby mode on, primary connection info, primary slot name, my backup, and then I started my secondary. Start the secondary and validate. PGCTL-D main, I should have said data, I apologize. The reason that the error is that I actually tested this on my laptop last night. I run Ubuntu, so the cluster directory is named main, and I basically copied and pasted. So assume main means data. I say start, and then I went into main log, and I tailed the log to make sure everything came up correctly. It says database was shut down in recovery, entering standby mode. Here's the LSN that my redo starts at. I've reached a consistent recovery state, reached at. Database system is ready to accept read-only connections. Don't worry about the invalid record link. That's normal. That's why it says log, not warning or error. Started streaming wall from primary at boom on timeline 1, and I am now connecting to my secondary on .5. I enter in my password, and there it goes. Shows that I'm on an SSL connection using TLS version 1.2 with various ciphers. Compression is off because of that bug in OpenSSL. I do /D to show a list of relations, and there's my little table. Boom. Replication is working. If I were to insert data, I was to create a new table on the primary, of course, it would automatically replicate across. That is literally, I mean, I know it's a lot of information, but it is not complicated. It's step by step how to get replication up and running. Now, we are now successfully replicating. So take a shot, celebrate, walk away. No, there is still more to do. What about that replication slot? We will want to keep the replication slot as it will protect against a secondary becoming out of date in the event of an outage or secondary disconnection. Monitoring replication. Replication is a great tool, but how do we know the state of replication? How do we know everything's working, right? On the primary, we have a system view called PGStat replication. The values of most interest are in bold. It's useful to know the other stuff, don't get me wrong, but if you just want to make sure it's working, if you look here, my state, I am streaming. I am actively connected. I have a slave or a secondary actively connected. I know things are being processed. And then, who is my username that's connected? Postgres. Remember, we do connect as a user to receive the replication changes. Who connected, in this case it was on my laptop, so it's 1.127.0.0.1. Don't care about the client port. Backend start, that's when the backend for replication started. My state is streaming, but now sent LSN, write LSN, flush LSN, and replay LSN all match. We know we are consistent. And it also tells us the sync state is async. It is not synchronously replicating. So the state, sync state, or did I do that? Sorry. No, the state can be one of the following. Startup. The wall sender is starting up. We're not yet replicating. Catch up. The wall sender connected standby is catching up with the primary. You are most likely only going to see catch up on the initial startup of a secondary when it's trying to get itself into a consistent state with the primary. Streaming, that's what we're doing now. All changes are being streaming. Backup, the wall sender is sending a backup. Or stopping, the wall sender is stopping. We're shutting down. The sent LSN is the last write-ahead log location sent on this connection. The write LSN is the last write-ahead log location written to disk by this standby server. Now, I want to stop there for a second. When we are talking about LSNs, the location, that is something that really only works with streaming. Because archiving is going to ship log at a time. One log, one log, one log. Streaming ships LSNs within the log. So it's more efficient. Flush LSN, last write-ahead log location flushed to disk by standby server. Replay LSN, last write-ahead log location replayed into a database on this standby server. Flush lag, time elapsed between flushing recent wall locally and receiving notification that this standby server has written and flushed it, but not yet applied it. This can be used to gauge the delay that synchronous commit level remote flush incurred while committing if this server was configured as a synchronous standby. It's important because, as we know, synchronous can slow everything down. It's really useful to know how much it's slowing things down. Is there something we can do? Do we need to bond another Ethernet interface? Do we need to change to an internal only interface? Those types of things. Replay lag, time elapsed between flushing recent wall locally and receiving notification that this standby server has written, flushed, and applied it. This can be used to gauge the delay that synchronous commit level remote apply incurred while committing if this server was configured as a synchronous standby. So we have remote flush and we have remote apply. Apply means the data is actually in the standby. So we can actually determine lag of applying our changes synchronously, whereas remote flush is all about, hey, the data's been shipped, it's on disk, but we haven't done anything with it yet. Sync state. Synchronous state of this standby server. Possible values are async, we know that one. Potential, this standby server is now asynchronous, but can potentially become synchronous if one of the current synchronous ones fails. Remember when we were talking back with the synchronous standby names with the quorum commit, where we could say first, and then say like 3, S1, S2, S3, S4, and then if 2 bounced out, 4 would move up in the chain. That's what we're talking about here. Sync, it is a standby or a synchronous standby, and quorum, the standby server is considered as a candidate for quorum synchronous standbys. On the lag times within PGStat replication, the reported lag times are not predictions of how long it will take for the standby to catch up. Such a system would show similar times while new wall is being generated, but would differ when the sender becomes idle. In particular, when the standby has caught up completely, PGStat replication shows the time taken to write, flush, and replay the most recent reported wall location rather than 0 as some users might expect. This is consistent with the goal of measuring synchronous commit and transaction visibility delays for recent write transactions. To reduce confusion for users expecting a different model of lag, the lag columns revert to null after a short time on a fully replayed idle system. Monitoring systems should choose whether to represent this missing data 0 or continue to display the last known value. Basically, if it's not null, then it's not idle and it's not necessarily up to date. That said, if they all match, you're up to date, but you're not idle. You're still receiving new updates. On the secondary, there is the ability to do a little bit of work on the secondary. You can, in regards to the status of replication. That is, that it knows about. It is kept in the system view PGStat wall receiver. This is actually a pretty big step up because we didn't used to have any information on the standby. It used to be the standby was just a black hole. Now we know whether we're streaming, what LSN we have received, the start of the LSN, what LSN we've actually received, last message send time, last message receipt time, the end of the LSN, slot name, and as well as your complete connection info, but it does hash out the password. So specifically, your PID is the process ID of the wall receiver process. That is the process that's connecting to the primary to receive the data. Activity status of the wall receiver process. Is it streaming? Is it stopped? So on and so forth. First write-ahead log location used when wall receiver is started. First timeline number used when wall receiver is started. Last write-ahead received LSN is last write-ahead log location, already received and flushed to disk. The initial value of this field being the first log location used when the wall receiver is started. Received TLI, timeline number of the last write-ahead log location received and flushed to disk. The initial value of this field being the timeline number of the first log location used when wall receiver is started. Last message send time of the last message received from origin wall sender. And last message receipt time of the last message received from the origin wall sender. And almost done. Latest end LSN, last write-ahead log location reported to the origin wall sender. Latest end time of the last write-ahead log location reported to origin wall sender. your slot name, and then your connection info. Okay, so this is where we need to make an executive decision. We can move on to logical replication. But if we move on to logical replication, we likely will not have much, if any, time for questions. So are there questions that we have now that are of consequence, or do we want to move on to logical replication? Okay, yeah. Okay, that's a good question. That would be a logical replication thing. So you cannot binary replicate between, say, 9.6 and 10. You cannot do that with binary replication. However, now with 10 and 11, you can logically replicate between the two, and yes, you could get that upgrade thing you were talking about. All right, I'm going to go ahead and start the slides. All right. So as much as I would love for all of you to show up to my talk tomorrow, you won't need to. The power of Postgres replication, logically speaking. We've already been through all that crap. All right, logical replication. We're going to be talking about what is it, how does it work, configuration, limitations, security, considerations, example architecture, neat tricks, and management. Differences over binary replication, why is logical replication good, and how does logical replication work? Binary is full cluster only. We discussed that. There's no partial binary replication. It is an exact physical copy. Binary is streamed or replicated byte by byte. Binary supports other functionalities such as point-in-time recovery. You can't do that with logical replication. Binary can be used for high availability. You can use logical replication for high availability. Don't. It's a bad idea. Why logical replication is good? All good things come to those who wait. The reason that's in there is because we've actually had logical replication for well over a decade. We had Mammoth PostgreSQL for a long time. It does pretty much everything that this does, but it was proprietary. We had Sloaney, we had R server. There was a lot of different ways to do it, but they were all either forks or bolt-ons. We now have built-in native logical replication. It allows publishers to push to a subscriber subset, allows subscribers to be publishers as well. That's key. Think about what I just said. Allows subscribers to be publishers as well. Now, you would think, well, you can do that with binary replication too because you can do cascading replication. That's not what I'm talking about. Okay, this is a different level of flexibility. And it just uses native logical decoding. I don't remember who it was that asked, but asked if you could put a middleware in between the stream. That's basically the logical decoding that you're doing that with. So how does logical replication work? It replaces the logical entries in the wall. It has a publisher-subscriber model. It uses replication slots. Subscriptions connect to the slot, meaning parallel streams. It is not SQL replication. This is a common misconception. MySQL has logical replication, but they really should call it SQL replication. And there's problems with SQL replication because when you SQL replicate, especially when you're dealing with, say, constants, so if you say select now, and now returns as this date, if it replicates select now to a slave, Select now and the slave is going to be a different date. So we don't do that. We actually replicate the logical result of whatever the SQL generated. So we don't get those inconsistencies. So let's do a simple configuration. If we're configuring logical replication, on the publisher, the master source or sources of data to be replicated to the subscribers. On the subscriber, the holder of subscriptions which connect to the publishers to receive replicated data. Now, there's a kind of an important distinction here because it can get a little confusing. A publisher has publications. A subscriber has subscriptions. But as previously mentioned, a subscriber can also be a publisher that has publications that another subscriber could have subscriptions to. Okay? Here are the minimum changes to the PostgreSQL.conf that need to be made. Your wall level must be logical. Your replication slots set to at least the number of subscriptions, not subscribers, +5. Why is this really important? You could have a master and a secondary, so a publisher and a subscriber, but within that subscriber, you could have 50 subscriptions or 100 subscriptions, and every single one of them requires a replication slot. So you need to set this accordingly. Logical replication takes more planning than binary replication. With binary replication, you're essentially saying, give me a continuous rsync and make sure it can connect and receive updates. I mean, that's what it all boils down to. It's pretty simple. Logical replication, because of how flexible it is a lot more complicated. Your max wall senders, you need to set max wall senders to max replication slots plus number of subscribers. Those are your physical connecting machines. Those are not your subscriptions. Keep in mind other connections that may use max wall senders. Remember that logical replication and binary replication can coexist. So you need to keep into account binary replication or backup software as PG Backrest or PG Based Backup. You need to create your replication user. And in this particular case, we want to make sure that we set password encryption to Scram. I said Sassel earlier, I meant Scram. Create user, rep user with password, super duper rad password, replication. Yes, you must still have the replication attribute. And yes, you really should switch to Scram. In this case, MD5 would work, but you should switch to Scram. And then you need to configure your PGHBA.conf to allow the subscriber to connect. Here's an example. We've already been through this once. An example, PGHBA.conf. If you look here, I'm saying any host that wants to connect via SSL to the rep test database as the rep user on any network, as long as they connect via Scram, is okay. And I go through this already on the list. Now that we've configured the publisher, we will configure a subscriber. We will then configure a publication and a subsequent subscription for replication. Okay, so this is for the subscriber. Modifications to the PostgreSQL.conf. Max replication slots equals the number of subscribers plus some. Max logical replication workers equals at least the number of subscriptions, not subscribers. Remember, a single subscriber could have 50 subscriptions. +5 for synchronization. That's important because it is possible to send multiple streams to sync your subscriptions. It can actually be faster than binary replication for syncing the database if you are replicating the full data set. because it will sync or flush, what do you want to call it, multiple tables, multiple subscriptions at a time. But and then max workers, I think that's actually supposed to be max worker processes, equals max logical replication workers plus one, perhaps more. Now remember when we were talking for binary replication, for max worker processes, we had to combine all of those values and then like add some, either ×2 or +5 or whatever. This is where this is coming into play. Because if you just set max worker processes to max logical replication workers +1, you may not have enough. Notes, remember when setting these values that a subscriber can also be a publisher. If your subscriber is also a publisher, you need to make the previously discussed changes to the PostgreSQL.conf and PGHBA.conf for the publisher as well. Publications exist on a publisher. Subscribers can also be publishers. You may have any number of publications. It is a one publication to end subscriptions model. Okay? So when I say I have a publication of table foo, I can have 50 different servers with 50 different, or each one with their own subscription to that single publication of foo. I don't have to create 50 different publications for 50 different subscriptions. They may contain a single table, mini table, or all tables. Creating our publication. Create publication, my pub, for table users, departments. Very simple. I now have a publication. I've got a database full of 1,000 tables. I now have a publication that says I only want to publish users and departments. That could be very useful if you were, for example, replicating specific human resources data to a subscription, but you didn't want to replicate everything else. In this syntax, my pub is the name of my publication. For table users department is the tables to be included in the my pub publication. You may also use for all tables instead of for table without a list of tables, which will create a publication for all tables, including tables created in the future. That's actually a pretty nice feature. What it's saying is, if I want to create a publication that's the whole database, I don't have to list out every table. Whole database right there, my pub. But I don't want to have to alter that publication every time I add or drop a table. So if I add or drop a table, the publication will automatically update. Advanced publication features, you can limit the type of DML allowed, the data modification language, for a publication. For example, create publication, my new pub, for table, table 1, table 2, with publish equal insert delete. What does that mean? It means that updates will not be replicated. Only inserts and deletes. Now, insert delete is kind of a weird one, but insert has a lot of use. If you think about a logging table, an audit table, all you want is anytime you add new data, you want that to also be translated or transferred. You don't care about updates or deletes. The publish option allows you to specify which type of DML results will be replicated. On the subscriber, create subscription MySub connection $, and then there's my con info. So DB name rep test host equals bar, user rep user, publication my pub. Now, look at the dollar quoting. Anybody here ever use dollar quoting? One or two people? Okay, here's the great thing about dollar quoting. Who here has ever tried to escape a backslash? Okay, escaping a backslash, it's a nightmare. It's backslash, backslash. I think it's 4 of them, isn't it? It's like backslash, 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 backslash to escape one backslash. Well, dollar quoting figures it all out. If you got a backtick, you got any character that needs to be escaped, it just knows how to deal with it. So you don't even have to worry about it anymore. You just use dollar quoting in all your stuff. This also works if you're writing functions in like PGSQL or whatever. It also works in your DML statements. So if you want to protect against SQL injection, you want to make sure no weird escaping happens, you can use $$ instead of quote. And it just figures everything out for you. It's magic. Now, it's not portable by any stretch of the imagination, so it is definitely Postgres voodoo, but it is beautiful Postgres voodoo. This will create a subscription and begins the synchronization process. Once synchronization is complete, incremental changes will be replicated. You need to be careful with large tables. The synchronization process is just a copy, aka long-running transaction. Long-running transaction bad because routine maintenance such as auto vacuum will not work during the transfer. Okay? So if you've got a 500 gig table that you're about to ship, think real hard about that. Logical replications limitations. DDL commands are not replicated. Alter table, create table. Use pgdump schema only. This is a little bit frustrating, and to me, it's a artificial limitation. We know how to do it because there's an extension called PGLogical that bolts on top of this that does it. We just didn't implement it for some reason. I don't know why. I mean, it might have been a time thing. But so you can use something like pgdump schema only to move your DDL across. Sequences, serial, big serial, and identity are not replicated. Number one, not the most important reason you can't use it for high availability, but the number one reason in this talk why you can't use it for high availability is that if, like most people, regardless of right or wrong, your primary keys are a sequence of some sort, and you replicate all this data, and you go to fail over, you're going to have a billion rows with a sequence value of 1, which means you will instantly get errors when you start to modify that data. So if you were going to fail over, you'd have to have this elaborate scheme of checking every sequence against the column that's associated with, grabbing the max value of that column, adding +1, and setting curval on every sequence, and then coming up. It would be ridiculous. There's just no reason for it. Truncate is not replicated. When I found this out, I was actually irritated at first, and then I thought about it, and it really shouldn't be, because if you truncate on the primary and it moves down to the logical secondary, the problem is the table that the logical secondary is getting replicated to might have multiple sources of data. So you'd have this situation where you actually have 5 sources of data in one table, but one master, one publisher, hit truncate and then deleted that 5 sources of data. So truncate is a no-no. Large objects are not replicated. Most people don't use large objects. Anybody here using PG large object? Yeah, I didn't think so. I actually like PG. It's non-standard. I like PG large object because it's much more efficient than byte A. The nice thing about PG large object is that if you put like a 90 meg PDF into it, and then you go to retrieve it, it literally streams you the PDF in 8K chunks. Whereas a byte A, if you put a 90 meg PDF in there and you pull it out, it sucks down the whole 90 megs all at once and doesn't release the resources. But it is non-standard and most people don't use it anymore. Here's some continued limitations. You can only replicate tables. No views, no map views, no foreign tables. There you go. Another reason you can't use it for high availability. Well, not the foreign tables, but the other two. You cannot create a publication that is a foreign table, a foreign data wrapper. Instead, you create the publication that is the source of the foreign data wrapper. So if you need the data from the foreign data wrapper, you just need to make sure, well, more specifically, it's going to have to be Postgres, but you need to, instead of other foreign data wrappers, but you need to make sure that you create a publication on where the source of that is to pull that data down. You have to replicate child partitions, not the parent. So you can't just create a publication that says replicate foo if it's a partition data set. It won't even work. You have to replicate the underlying tables. It is best to have a primary key. You don't have to. You can say something like alter table, rep test, replica, identity full. But if you do that, what it essentially does is every single row that gets replicated creates a where clause of where column equals column, column equals column, column equals column, all the way across to get a unique row. So if you got a 50-column row or table, it's hugely inefficient. Just do the right thing and have a primary key like you're supposed to. I mean, you're supposed to have a primary key anyway, so just do that. Limitations, conflicts. This is the big one why high availability just does not work with logical replication. Remember that a subscriber is writable. It's not a read-only device, unlike binary replication. If you change data on a subscriber table, the data between the publication and the subscription may differ. Further, conflicts break replication. So unlike binary replication where you really can't do anything to break a slave, at least from Postgres, I mean, you can break it underneath from the OS, but in Postgres you can't really break a slave. The problem with logical replication is there is no slave. There's no read-only. You are a subscriber to a publisher. And specifically, you have a subscription to a publication, which means that your subscription is writable. You could have multiple instances of things coming into that table, multiple subscriptions into that table from multiple publications. Also, you could, if you wanted to, for whatever reason, just say update foo set bar to 1. And then all that data updates, and the publishers don't know or care. So you can break your app. But worse, and that's actually by design because you get a lot of features that way. There's a lot of things you can do. But the problem is, let's say you update everything on the subscriber. Everything's fine, but then your publication sends over a row that violates a foreign key because of the changes you made. Replication stops. Stops cold. It is now broken. You have to fix the error and then resynchronize. It's just, which is not what we want with high availability. What we want with high availability is I fail over, it works, everything's good. That's what we want. The following will not work. This I actually asked about this when I was writing this content. It is not a limitation of the features or the logical replication. It is a limitation of time. They just didn't get around to it. This would be very useful to me on a publisher. When I say public.foo, I am talking about schema public table foo replicates to the subscriber schema private.foo. That would be, think about a situation where you've designed an application where every single client has their own schema and their own set of data within that schema. Instead of a bunch of databases, we got a bunch of schemas. Well, it may be nice to say, here are my EMEA clients. Here are my US clients. But I only want that for my central data store where I'm doing reporting. Also, publisher public.foo replicates to subscriber partitioned public.foo. That does not work either. That is even more useful if you think about a scenario where you have a bunch of edge servers that are processing transactions that are maybe sending down audit logs or something like that to a central store. And then you want to be able to partition that data set. Further, as I mentioned, the replication doesn't work quite right with partition tables, but there is a way around it. Special care must be used. And this is how you do it. In order to replicate partition tables, you must create a publication which contains each base table within the partition set you wish to replicate. For example, we create our table part test, very simple, ID big int test text. Primary keys don't work on partition tables. That is no longer true. As of 11, primary keys work on partition tables, just not as of 10, which is what this was written on. We create table part test 0, partition of part test for values from 1 to 100. We create table part test 1, partition of part test for values 101 to 200. Then I can create a publication part test for tables part test 0 and 1. Notice I'm not replicating the parent table because the parent table is essentially an envelope. It doesn't actually exist. Everything is getting put into the buckets below it. Security. The role used for replication connection must have the replication attribute, showed that earlier. To create a publication, the user must have the create privilege in the database. To add tables to a publication, the user must have ownership rights on the table. To create a publication that publishes all tables automatically, you must be a super user. To create a subscription, the user must be a super user. Now you would think, why is that the case? Well, you don't want any arbitrary user to be able to connect to any arbitrary publication and start pulling data. So if you are creating a subscription, you must be a known, admin rights user. To create a subscription, the user must be a super user. I did that one. The subscription apply process will run in the local databases or database with the privilege of super user. That's important because the objects don't need to be owned by a super user. But when you pull that subscription down, it is going to be a super user. So it's kind of like a loophole for security to make it work. Some considerations. Each sync is an internal copy and snapshot. That was to beware of long-running syncs because it's a long-running transaction and it will affect auto vacuum and it will cause bloat, period. You need to prepare for that and manage for that. Each replication slot is a separate connection, thus parallel streams, which in turn can cause a copy. That could be a potential performance hit, long-running transactions, and or cause bloat due to limitations with vacuum, auto vacuum. Also, remember max connections. Okay? I think I showed you this before. This is an example architecture where we've got our human resources app plus full subscriber to SalesDB. Then we have public-facing SalesDB, read-write SalesDB. It's using logical replication to create a single canonical database of full subscriber plus the HRDB, which uses binary replication for a hot standby. And then over here, we have a DR hot standby of the SalesDB. So we are integrating both. I have a second one, I believe. Yeah, here's the second example architecture. This is actually one of my favorites. This is from a potential client that they have a set of data that must be published to a particular location, and then they have another location that has a set of data that needs to be published to the original location. But here's the catch. They can't touch each other. Okay? So what we have is USA primary, table group A. So we've got a group of tables that will replicate to the Asian primary so that they have access to that data. But they have a table group B, which is a completely separate group of tables. It's not ABC, they're DEF. They have to replicate back to the USA. And then, of course, we do have an async binary replication for the Asian primary and then a synchronous binary replication for the US. This is a great example of where logical replication can be useful. Because you have a scenario where or it doesn't matter which one you pick, but the Asian primary is not allowed to, for regulatory reasons, connect and use this application. And the US primary is not to, for regulatory reasons, able to connect to the Asian primary. But there is specific data that they have to exchange for their services to work. And we're able to do that with logical replication. We would not be able to do that with binary replication because it would violate the rules, the business rules. Some neat tricks. This works. I believe someone asked me about this earlier. Create table foo, bar text, baz integer, replicates to subscriber, create table foo, bar baz employees. That'll work. The other way won't. You cannot invert that, but you can do it this way, which would be great because then you can have a situation where table foo, I don't know why I picked employees, but you would update employees on table foo on the subscriber based on, bar or baz, and it has nothing to do with what the publisher is doing. The publisher only needs to have the data that it needs. It is just native logical decoding. It's just integrated now. So we can replicate to Kafka, to MySQL. Like I said, don't do this, but there it is. Mongo, PGLogical, which is an extension that has added benefits like schema replication instead of having to use like PG dump all schema, as well as some conflict resolution. All right, a little bit of management. How we manage the publications and how we manage the subscriptions. We can alter a publication. So it's not like the publication is static. We can add a table or all tables using star. We can set a table only to a table name. We can drop a table. We can set a publication parameter. Remember when we were talking about changing whether or not you did insert and delete only for the DML? You can change the owner of a publication, and you can rename a publication to a new name. Subscription gives you a little bit more. You can alter the subscription, the name of it, how it connects, what the publication name it connects to. You can refresh from the publication. You can enable it, disable it. You can set specific values. You can change the owner, and you can rename it to a new name. You can monitor it with PGStat subscription. I didn't do an output of this, but so you've got your subscription ID, which is the OID of the subscription. You've got your subscription name, the process ID of the subscription worker, the relation, the OID of the relation that the worker is synchronizing. This is interesting because what you would be able to do is actually map that in PG class and know if you have a subscription that has multiple tables, you'd be able to know exactly which table is currently being worked on. Received LSN is last write-ahead location, last message sent time, as well as receipt time. We've talked about that before. as well as the latest end LSN last write ahead log location reported to the origin wall sender, and then the latest end time the last write ahead log location reported to the origin wall sender. And that's it. I mean, we've got some time. We've got 10, 15 minutes if you guys want to take questions. If not, that's cool too. Yeah.
Hi, thank you.
Oh,
One. Oh. I will talk in English, it's okay.
Oh, you speak English?
Yeah.
All right, go ahead.
So I would like to know, if we replicating information to Kafka, what format will it be? Is it pure SQL or how?
Well, it depends on how you do it. If you are using the logical stream decoder for Kafka, it is going to be in the standard Kafka format. I don't even actually know what that format is, but I know it'll be native to however you send it to Kafka. And you can modify that because it's just a queue, right? So however it is that it accepts the queue natively would be how you would do it.
Is it possible to track all the changes, like inserts, in the same format as it was? You said that it is logical result, not the queries itself replicating. So may we have a queries itself, like inserts, to provide them next to the next sources through Kafka?
So you want to audit all changes and you want those changes shipped into Kafka?
Yes.
Yeah, absolutely, because now it'd be a little tricky because you can't, there's no native auditing to Postgres. So what you could do is install the extension like PG Audit, and then you would create a publication of the PG Audit tables, and then you could create, through the logical decoding, you could subscribe to that publication and then ship it into Kafka.
Oh, I got it. Thank you very much. It's
You're
very
welcome.
useful. Thank you.
Anybody else? Oh, over there. Oh, while I'm just curious, I have no idea if that's accurate. Google told me it was. Thank you. Okay, good.
It's correct translation. Thank you for your time. I have a question. Please tell your vision about a situation known as split brain. Maybe with some solutions examples.
Split brain?
Yes.
Okay, so for those that don't know, split brain is when you end up in an environment where you had a primary and a secondary. The secondary promotes, and now you have a primary and a primary. And how do you deal with that? It's a little tricky. So in Linux, the best way to handle it, and it's also the most complicated way to handle it, is you got to use what's called fencing. And when fencing, what happens is that when the HA cluster determines that it needs to fail over, it won't allow a split brain scenario because it literally cuts off the former master and the secondary comes up. But in order to do that, you have to use the Linux HA tools, and they are anything but simple, okay? The other option that you can do is use a single floating IP. And this is the most useful option in that, or simplest option, because what happens is, in the event of a secondary promoting, even though the master is still valid, everybody's connecting to the floating IP. So that floating IP is going to ship to the secondary, and although you technically have a split brain at that point, you don't, because all your applications are only going to connect through that single source. So yeah, you would have to, you're on the single source and the secondary has been promoted, and then you would have to demote the primary and then turn it into a secondary, but you don't have a situation where applications are trying to figure out where to connect and data is being updated in different places. The biggest point, where I run into split brain the most is if people are trying to use DRBD for HA. If you don't know what DRBD is, I don't remember what the acronym stands for, but it's block level replication of your disks, of your volumes. And it is known that if you're not careful, that you can get a split brain where you literally have two Linux operating systems with replicated file systems that think that they're in charge. But if you're not doing that, avoiding split brain, it's not impossible, but it's not that hard either, especially with the floating IP.
Okay, thank you very much.
Okay. Anybody else?
Спасибо. У меня вопрос про бинарную репликацию. Я правильно поняла, что ее можно настроить, не настраивая слоты репликации? Вот. Если это так, то в чем риски? То есть зачем настраивать слоты?
Yeah, you absolutely can set it up without the replication slot. You could either use archiving, which would ship the logs in case of disconnection. The biggest risk of not using the replication slot is that you will, if you're not archiving at the same time and the secondary disconnects, you could have a situation where you overrun essentially your max wall size, and then when the secondary reconnects, it'll be out of date. It won't catch up. So you can't safely do it without either A, a replication slot, or B, archiving. If your situation is that your secondary can't talk to your primary, which is often common, use archiving. That way the primary can ship the logs to the secondary so it's always up to date should it get disconnected. Does that make sense?
Спасибо.
Next.
Excuse me, some people were asking for QR code for the last presentation.
Oh, we don't actually have one for the last presentation. So the QR code, I do not actually have a QR code for these slides, but I will make sure that the organizers get a copy of them to post up. These are free slides, so I'll make sure they get up. Do you put your slides on the site? Do you know, on the PGConf site? Anybody?
Not sure.
I'll make sure the organizers get them. You can request them. It won't be a problem. All right. Any other questions? All right. Thank you very much. You guys have a great evening.